Create new project in here for unit 7. Create a package. This is just Java.strings package. We have a class. String class. String class examples. How's that? All right. So this is the immutable string. So again, all strings are immutable. That means you cannot change. Usually they'll say it's data, but really just data inside the constant pool. Okay, you cannot change it. Okay, and really, if you add something to that string, you actually recreate the whole string again. So it's always a new string every time. It's not. I mean, it seems as if you're actually adding. You're just changing the data, but it's not. It actually recreate the whole thing again behind the scene for you. So that is why you cannot change the data. Once you assign something to that string, it's fixed. It's constant. And then if you add another string to it, it recreates the whole thing over again. Okay, so that's why you cannot change it. And that's why it's called the constant string pool. It's always constant. So string, we'll call it word 1. We'll put the word in here for apple. So now that when you run this, JVM goes into the pool and looks for that word apple. Right? In this case, there's none, so it will create that for you in the string pool. And so the object exists, and until you exit out of the program. So this is also true if you are calling this in a different function. It doesn't matter which function you're in there. It's going to be the same pool because I can still check the data, right? So now, when that is created, if you create another string for word 2, and whether you say apple or equals to word 1, it doesn't matter. Okay, it's still going to be the same thing in this case. So they're both on the same, point to the same object and the constant pool, and that's why we're able to equate them. Okay, because they're pointing to the same memory location in that pool, and so when you compare, when you system out word 1 equals word 2, that will always be true because we think it's comparing the value, but actually it's that memory address. Okay, so that's why I have too many equal signs. Think of JavaScript. So when you run this, it's logically it's going to be true. Did I do something wrong? Well, some issue. I'm going to just reboot this. I think it doesn't like the Java. How did I this package here? Okay, let's try a different package. Let's try with bad naming. Call it Java strings and just one word then. I think it doesn't like this. It has there's no string Java. It thinks I'm using that built-in package. So let's see if this makes any difference. I'm going to move that over here. and I will delete this this package. Let's see if that's the case. Okay. Yeah, so the Java dot something is reserved. Completely forgot about that. So okay, so that's what equal to we're able to check their values as if they're equal. So it's pointing to the same location. You can also do like string 3, right? String 3, word 3 equals word 1, right? You can do that. You can use that all the time. And if you check word 1 against word 3, okay, should be equal, right? They're the same, points to the same data and the same object and that constant pool. So, like I mentioned, okay, so now 1 and 3 are equal. That means if you change word 1 to a new word, then you would think that, well, since they're already equal here, I'm assigning 1 to 3, pointing at 1. Now 1 is changed to a new word. You would think that 3 and 1 should still be equal because, you know, how they're chained together, right? And because they are a string, they're immutable, so they're not. You cannot change the data, so therefore it's not the same. Okay. So if you will like sys out word 1, put a space, and word 2, 3, right? They are completely different. Okay, they're not equal. So even though I assign them this way, and I change those words later, it does not affect 3. And if I change 3's data after that, it does not affect 1. Okay, so they're constant. Once you assign the data to string, it's constant. And you may think like, okay, if I do like word 1 is equal to word 1 plus word 2. Yeah. Okay, so this is like you're adding word 2, which is apple apple, and we'll make 3 here. So it's apple Google 2 1. And the way you see it is like, okay, I'm appending the word Google to Apple. Okay, it is not. That's why it does add the Apple and the Google together, but then it recreates this whole thing again. It gets recreated in memory. Okay, so you're not really just appending them together. It's the way we say it, or we see it, it looks like that, but and behind the scene, it's not. Okay, it assigns the new values to itself, and the value is Apple Google. So those are immutable. Now let's look at mutable data. And mutable data are reference types. Okay? Mutable strings. These are the string buffer and the 2 types, string builder. So when we use mutable strings, you can use either one. And these are special classes, so when you use them, I think you have to import them into the program. Okay, just like the scanner. So if I go string buffer, we'll call it SB1, I guess, equals, notice I cannot do like your usual string type, okay? Because these are objects. So remember, if your objects, you have to use the keyword new, right? New string builder or string buffer, and then it takes that value. So that means you have to go new string buffer, and then you can add that inside the paren here. Okay, now I'm adding the string to that variable sb1. So if I were to print it out, so if you do like system out, if I put sb1 like that, like we did with the word and up here, save, print. So you got bird. Okay, so just like that. And let me turn this up here off. We don't need this for now. Okay, I'm going to create another string buffer. This one we'll call sb2. Call new string. And we'll put like cat in here. So there are two separate strings. Two. It should work. Bird and cat. Okay. Now I'm going to do something like we did up here when word 3 equals word 1. Let's see what happens. So I'm going to say sb2 equals sb1. Right? And I'm going to print them out. sb2 should be bird, right? So we have bird and then cat, sb2, and then sb2 we assign to bird now has bird. Okay. And let me just do something really quick so we can see. Put that there. This is 2 and 2. I put like 2, let's put something here. Before, this is after. After we change this data. And I want to print sb1 out also just to make sure it's still. Also, this is after when sb2 has changed. So it should still be the same. Though both of those should still be bird, bird. So we have cat and bird, cat, and then bird and bird, right? So we have the bird, cat, and then the bird and the bird. Okay, so over here now, I'm going to change sb2 to a new word. So you cannot just do like sb2 plus is q, right? I can't just do that because it's no longer a primitive string. To add string like this, the way we did up here, when we add like a word 1 plus word 2, like that, I can't add a string like that. Okay, I have to use a function that is built inside the S2 here. So something called append. I could have the append. I want to add this new string called is cute to it, to S2. So I'm going to print both of them again after that. Let's save it. Run it. Okay. So you see that at the end here, S1 is also been affected, right? I did not change S1's data at all. I changed S2. So initially it was they're both separate here. And then line 20, I changed SB2 to SB1, so now they're both equal. And then line 23, I changed SB2's data. I added the word is, the text is cute to it. And you can see that the last one, I did not touch S1 at all. That's also been changed automatically, right?
So they became the same object.
Yeah.
Yeah. So,
So the same.
One to the other, it became a pointer to one object.
Mm-hmm. Okay, so they point to the same object. But if you look at this, if you remember the notes, these also point to the same object, the S2 and S4. But how come when you change S2's data, it didn't change S4, right? And that is the distinction between mutable and non-mutable. Okay?
Yeah.
So if you're using the string buffer or string builder and you do it this way, anyone you reassign one to another like that, at that point, S2 loses its data and it points to S1. So now they're pointing to the same account, same location. So you're changing one affects the other after that point on.
So the old object no longer has a pointer over the
Yeah. And then it loses the other one, and then the garbage can and collect that one. Right. And so this is a what's called a mutable strings or mutable objects because you can change the data. Okay. I'm not really like when I do this, I'm not recreating the object. If I do that, I would have a different memory address already, and it wouldn't equal. It wouldn't work. But because it's still the same object, I'm just patching something to the existing object, so the address is still always the same. It's just the content changes. Okay, so that is mutable. So when you create your own class, like a class called I don't know, student, and if you create two student variables, like student 1 and student 2, and if you make them equal, it's the same thing, exactly the same thing. So if, at that point, if you change student 1's data, it affects student 2 because it's pointing to the same object. Okay, so objects, when you create them, are automatically mutable. Okay. There is a way you can make it non-mutable. It's just by doing that, you make that class final. Okay, you make it final, then you cannot create other objects, or you cannot make that, it becomes immutable. Kind of like a string. String is like final. And the reason why Java chose to use string and make that immutable, not changeable, is because we use the string class a lot in our program. Because we use a lot of them, and if they're not, because sometimes you'll reuse this word again and again and again, right? Because not only in this class, this function, I might use it in a different function in the same program, has the same word all over again. I'm building a lot of memory and RAM. It's going to consume all those memories. So instead of doing that, hey, this is like one of the strings that is used the most, and we'll just put into the constant pool. So that when you build that string and you have the name, you just use whatever already existed, save you RAM. Okay, so.
I guess you can see Java's origins to be very small.
Yeah. Mm-hmm. Yeah, you can think of that way. Right. So this little thing had to be written in Java, right?
Yeah.
Yes. So I said, no, it's not that. So. Okay, so that is immutable. And if you want to find out more about these type of strings and what they have, like what kind of functions they have, and this IDE always tells you sb2 dot, and it gives you a list of all those built-in functions you can use. You can convert to strings, append a character, append an object, append an integer, the length of that string, You can set the length to a different length and size, and so on. Okay, so that is built into this type of string. And this one up here, if I want to comment this out, put word1 dot, you see all built-in function as well. You won't see the append. There's no append in here, as you can see, right? Because you cannot add to itself. You cannot change the data, so append is not part of it. The other one is they're mutable, so you can keep adding strings to it. But string itself, the string type doesn't have that append function. You can check the equal or not equal. You can check the length and get the substrings and things like that. But you cannot add things to the string because you cannot change its data. Okay, but these are available for you, and you can check those. You can get the substring. You can check. Let's see. You can get the check if it's empty or not. Let's see. One thing. Let me see if I want to show you. It's in one of my videos. If you watch it, you'll see it. Let's see. This one has sb2 hash code. Okay, the hash code here tells you their address. Okay, and let me see if that shows up in here. So I put SOUT, I put SB1 hash, and we'll put here SB1 that has hash code. That tells you a hash, gives you a hash code. It's like a code that points to the memory address. And I'll do one for S2 as well. See if they're equal. Okay. So run this here, and you see that they point to the same memory address. Okay. So that's why they are immutable. You change one, I change that to its Q, it affects that one too because I'm pointing to the same object. I just have a different name. It's like a different person, like you and me, we or Charles, and then Paul. We can all have 3 different objects. We can share the same credit card account. So you use it, affects me, affects Paul, and vice versa, right? It's the same idea. It's just a different placeholder pointing at the same memory location. So that's for that. We can also check for the other one up here to see if they are the same or not. And let me turn this back on. So let's go for the word. We did 3 and 1. So 1, word 3, because we had that equal here, right? So I comment that out. So we said word 1 and word 3, they're equal. I signed those two together. So if that's correct, then word 1 and word 3 should have the same address. Word 1, word 3. Okay.
So pretty much all objects have a hash code.
Yeah, all the same hash code. So as you can see, they have the same hash code, same address. They say, well, yeah, because I signed that, right? S3 and S1 I assigned in line 10 and make them equal, so kind of like I did down here, where I put S2 and SB2, SB1, so that makes sense. But what about if I do this? Okay, fine, then S3 is not assigned to S1 anymore, but it contains the same string. So it's still the same code. It still points to the same object and that constant space. So now, even though S2 or 3, 1 and 3 are completely different variables, they point to the same word, and it's in the constant pool. They have the same address. Okay, and to show that the other one, let's just say that I did not do this for 25, right? I did not assign SB1, SB2, and let's just say that I also add SB2, the same word as SB1, which is what I add. Oh, bird, right? Let's just say both a bird. Okay? And I will change, I'll just show those data. I remove all of them. We'll just show that SB2 also has the same word. So they have the same word as up here. Word 1 and word 3 has the same word, and they share the same address. SB1 and SB2 have the same word. And let's see if their hash numbers are the same or not. Right? Completely separate. Okay, so they share the same value, but they're a different location in RAM. So that's why you cannot equate them just by saying SB equal to SB2.